Hey, this is Mr. Beckstrom, and today I'm going to take a look at number 8 in section 8.2. And here it says two sides and an angle are given below. Determine whether the given information results in one triangle, two triangles, or no triangles at all. Solve any resulting triangles. So this is another case where we're going to have a side-side angle. It goes like this, a side-side angle. This is similar to the side angle side, except that this means that the angle is not going to be between our two sides. So the side angle, notice that the A is not between the two S's, and that's going to be the same with the triangle. The angle is not going to be between the two sides that we know. So in order to set this up, the way I like to do it, and the way that the book does it as well, is we're going to just make a ambiguous triangle here, and let me turn that off. Oops. All right, and so the known angle we're going to put in the bottom left here, so 40 degrees, and the corresponding side, so the side opposite it, so big B is 40 degrees, so little b is going to be 7. So that's the side length opposite our known angle here. And then the other side that we know is 9. The other side that we know is 9. And what I want to do here, and I'm going to drop a dotted line straight down here, and we're going to call this length the height. And notice that that forms a right triangle here. This side here, what we want to do is we want to see how long this is compared to the height and our side over here. So it has to be at least as long as the height in order to form a triangle, because if it's shorter than the height, then it's not even going to be able to reach the bottom here to form a triangle. So if it's not at least as long as this height, then it cannot form a triangle, and we have no triangles at all. Now, if it's at exactly the same length as the height, then it will just barely reach the bottom, and we'll have a right triangle here. If it's greater than the length of the height, this length side here, the 7, if it's greater than the height, but it's less than this side here, then we can actually form two triangles. We could actually form one going this way like this, or we could form one going this way like this. So in that case, we'd actually have two triangles. And then the last case, and let me go ahead and erase, I'll go keep those, just do another. If the length of this side was greater than this side over here, which it's actually not, but then we could actually just form one triangle that went way out here, like this. Kind of like this here. So those are the four cases that we have. So really what we do is we need to check this height and then compare this value here to the height and this value over here. So in order to find this value here, the height is just going to be equal to this side here. So that's going to be 9 times the sine of that angle there. The sine, and look at my last video, and I'll show you how to do that, but you can really just set up a sine function is equal to opposite over hypotenuse, and then solve for h there. So h is equal to 9 times the sine of 40 degrees. And in this case, let's figure that out. Mode, we're in degrees. So 9 times the sine of 40 degrees is equal to about 5.79. We'll go 2 decimal places. So about 5.79. So that means that this is 5.79. This length here is 7, and this side here is 9. That means this length here is greater than the height but it's less than this length over here, which means that we're going to get two triangles. That means that this side length can come on this side, or we could kind of swing it around and make a triangle over here as well, because it's less than this length over there. So in this case, we're going to have two triangles. So let's actually go ahead and figure both of those triangles out. And in order to do that, let's kind of write what those are going to look like here. So we're going to have one that kind of swings out this way, and then we're going to really have one that kind of swings back in this way. And these aren't extremely what they're going to look like, but close enough here. So these are going to be 40 degrees. This is going to be 9. This is going to be 7 here. This will be 9. And this will be 7. All right. So we can use law of sines here. So I'm going to do the sine of 40 degrees over 7 is going to equal, and then we can kind of solve for this angle first. So we're going to do the sine. We can call it anything we want, but since they called this 9c, we'll call it big C over little c, which is 9. And this is going to give us that the sine of big C is equal to, and cross multiply and divide, we're going to get 9 sine of 40 divided by 7. And this means that C is going to equal the inverse sine of 9 sine of 40 divided by 7. And remember, with the inverse sine, what we've talked about is that there's two angles between 0 and 180 that we have to look at. We have to look at the one that we're going to get here, plus we also have to subtract the one we get here from 180 and look at that one as well. And since we know that we're going to have two triangles, then we're going to also know that both of those angles are going to give us triangles here. So let's go ahead and figure this out. We already know we're in degrees, so I'm going to do the inverse sine. So inverse sine of, put the top in parentheses, 9 times the sine of 40, and divided by 7. All right, I think I have the correct number of parentheses. Okay, so that's going to give me about 55.7. So this is about equal to 55.7. And we're going to call that C1. And we're also going to have C2, and that's going to give us 100, and that's going to be 180 degrees minus that 55.7, and that'll be our second triangle here. So this big C over here is going to be 55.7, and then for our other one over here, for this angle here, that's going to be 100 minus 55.7, 180 minus 55.7, 180 minus 55.7, 124.3. So this angle there is 124.3 degrees. All right. Now we can easily find the third angle on those just by, for this first one, we're going to do 180 minus 55.7 minus 40. And we get 84.3. So 84.3. We'll finish off the angles for this first triangle. And for the second triangle, we still need to figure out this angle as well. So we're going to go ahead and do 180 minus 40 minus 124.3, 124.3. And that's going to be 15.7 degrees. Very small, 15.7 degrees. And then the last thing that we need to figure out is this last side, which I'll call this one down here B1, and I'll call this one down here B2. And we can do that with just using the law of sines. So you can do the sine of 40 degrees over 7 is equal to the sine of 84.3 over B1, and then solve for B1. And then for the second triangle, we can do the sine of 40 degrees over 7 is equal to the sine of 15.7 degrees over B2. That should be B2. And I'll let you all solve that. And I hope this helps. If you have any questions, let me know. And have a great rest of your week. Thanks.